Percona Live 2022. And our great guest today is being inducted into the Open Source Hall of Fame, Bruce Momjian. And we do expect you to keep doing great things after you're inducted. This isn't the time to go. We're not trying to give you the shovel push out the door.
I had to ask, I don't know. It's usually they wheel them up and, usually they get the lifetime where somebody has to help them get on the stage and then somebody has to help them get off and they don't get lost, on the stage. So they usually they keel over a couple months later. So no.
So was it 26 years ago you started on this thing that was called then Ingress?
Yeah. No, it actually was Postgres at that. Yeah.
And what was attractive to a young, dashing young man who's now a grizzled veteran?
It's funny when you called me, I guess a month or so ago and asked me about it, I started to think about how did you get here and what brought you. And I think one of the unusual things is that a lot of people are sort of programmed to just produce and consume. It's just getting into that rat race and just become a cog in that big wheel. And I think one of the things that has made me unusual is that I get kind of interested in stuff, whether it's, sometimes I don't really know why, whether it's because I'm intellectually stimulated by it, I feel that that's where I should be. It just feels right in terms of the type of work I'm doing and the growth I'm feeling from it. And you don't want to kill your career doing it. You don't want to injure your family with doing it.
Yeah.
But a lot of times there's ways of getting involved in things, not just technology, but overall, where you feel, I really should be part of that thing. And a lot of people, I think, steer away. They're like, oh, I'd have to quit my job to do that, or I'd have to move or whatever. And what I found, surprisingly, is that the incremental approach is usually better. I think sometimes they don't do it, and then they jump in with both feet, and it's really hard.
Yeah.
Fortunately for the way I did it, I'd been a consultant for many years, 7 years at that point, writing legal applications, law firm applications.
And this is after several years of teaching school.
Yeah, after 5 years of teaching school. So, you're 12 years in and it's time for something that's really going to challenge you, intellectually. And fortunately, I came upon Postgres at that time. And it looked really interesting. It looked like it had a lot of potential, but it needed structure. It needed somebody to kind of shepherd it forward.
And a law teaching background is just the perfect match.
Yeah, it really kind of fit. And I was able to do it, in the spare time for 3-4 years before I was fully hired. So, every day you do a little bit, and you're like, oh, that felt really good. My family still likes me. I still have a job. But I'm moving the ball down the field, right? And a lot of times, if I think back in '96 and I think, well, what really triggered it? A lot of times, big days in your life, like, okay, I graduated from college, I got married. Those are big days. Those are big days. But then there are other days that are big that you don't really know until you look back. Right, years later, you look back, wow, wonder why I did that, and I'm glad I did. So that's, I think, the thing that what really got me involved was it felt like the right thing to do. It felt like it was going to help me become a better engineer. It was going to help me to be involved in a global community. I was pretty good as a legal consultant. I was known very well in the Philadelphia area, but as soon as I started working with Postgres people around the world, I felt 2 inches tall, as people should. But so, when you're surrounded by that capability, you over time, you get a lot better quickly, and that was incredibly stimulating for me.
I've always contended that writing a database is more work engineering-wise than writing an operating system. With an operating system, you can check, pause, change context. Your database, the drummer and the bass player have to keep going while you're moving stuff around. And after 26 years, is there one piece of code you have to keep rewriting because you don't have it yet, or you write it and you go, that's good enough for now?
The most hilarious part is that almost every major piece of code that I've written has eventually gotten ripped out. Yeah, everything. Temporary tables. I did a macro for looking up offsets of rows. A whole bunch of like scripts I wrote. And so what was funny is that I would, we would have a need for the project, and I would roll up my sleeves. And the joke is I just run into the burning building, and then I call when I'm on fire, and somebody comes and gets me out, right? So I guess maybe unwisely or wisely, I just run into the burning building. I get it done. It works. You kind of don't want to look at it too closely, but it passes every test, and nobody complains. But in every case, about 3 or 4 years, the macro thing went a good 15 years, but usually it's a 3 to 5 year period where somebody goes in and they look at it and it works, but they're like, this is really not the way to do it. And it gets rewritten, and it just kind of fades away. And then I'm also working on a new thing that will again be ripped out in 3 or 5 years.
And that's how you get into the Hall of Fame.
That's how I get into the Hall of Fame, right? Is the burning building, and then writing things that people originally eventually have replaced with something much better, But usually I have a tendency to steer through the expedient. So we kind of design things so they work and they don't look terrible, and they're not a reliability problem. But style-wise, usually the project evolves, and I wave goodbye to the code, and I see the commit that makes it leave. And I'm like, oh well, there it goes.
Well, how many times in your career have you opened up, in a text editor and look at the code and go, oh my God, this is horrible. Who wrote this? Me.
The macro was the worst one, because what we basically found was that when we did profiling, the computation of offsets into rows was a function call, and the function call was really slow. It was being called all the time. So I basically wrote a macro, and you might see macros, they're basically like a line with some arguments, and you put some code. Well, this was almost a page full of macro with sort of / line continuation. So it was this humongous amount of block of code that inlined this very important thing that we called all the time. And it looked pretty wonky to look at it. But what actually fixed it was better support for inline functions in C. So eventually, the reason it kept getting delayed is because all of our compilers had to support that. And we finally, I think, retired the last compiler literally 3 months ago, and the macro went bye-bye. So it didn't look great. I knew I wrote that, and I was kind of marveling that it had carried on for so many years. And sometimes I look at it and I'm thinking, somebody's got to come along and do something for this. But
well, luck plays a certain part of any project's life, and there are some things about Postgres that have been there like now that are now paying off unexpectedly, like the way it fits into the cloud so easily. How do you quantify? Well, you really can't quantify these unknowns because.
Yeah, I in a lot of ways, I think it must have been when I was speaking in San Jose at one of our conferences. We look like geniuses, right? Because like when the SSDs came along, the only thing we had to change was we have a random page cost, and now we needed to specify that at the table space level of magnetic and SSDs. That was about it. Even though SSDs are a major redesign of capabilities, random versus sequential cost. Yeah. And when we went to the cloud with containers, VMs, there was virtually nothing to change. Partially because we've been very lightweight, and I think the overall strategy is the joke about premature optimization, that we have a tendency not to steer onto the simple side, because I've seen a lot of cases, and a lot of our engineers as well, where you can make something complex and maybe get a couple percentage points out, but then the code becomes so complex you can't optimize it anymore. Can't optimize it for new workloads. Nobody really understands how it works. It might tie into behaviors that are fluid, or they come and go with different operating systems and so forth. So, a lot of our strategy has been that simplicity. we don't try and squeeze out every percentage point of performance because we know if we do that, we could potentially disable later optimization that would be more significant. So yeah, a lot of it's luck. We were certainly at the right place at the right time. If you look at how Postgres installs in the cloud, for example, it looks like a genius. It just installs in like 30 seconds and you're up, and it's got all the crash recovery and everything's using the native file system, and there's replication if you wanted, and but a lot of it is saying no to stuff, really. Not actually saying yes, but saying no to things like remote devices, saying no like the things that might tie to specific operating system features, or just making the code complex to try and get that extra percent, and then being unable to really unwind it later when you want to, take on it, go in a different direction.
Yeah, the engineering got just too hard to do anything. And that's why I think a lot of projects end up dying after 4 or 5 years, because you paid yourself in your corner and it's easier to start with a white sheet and go on. Put on the resume and otherwise ignore it.
Yeah, one of the things that I realized, actually back to my time when I started with Postgres, is that, in the first couple months, I guess, or probably a year, I would try and tackle hard problems. And some of them I succeeded, some of them I had to call from the burning house to get somebody to help me. I had a guy in Russia who was always my go-to, get me out of the burning house rescuer. But what I realized after about a year was that as good as I am maybe as a coder, I was probably going to get more done by enabling other people. Because when I started to look at the size of the community and the skills of people who I was working with, I'm like, okay, I'm good, but these people are really good. So I'm better off giving them a platform and giving them tools and giving them a code base that's easy for them to work with. So I started writing presentations. Very early on, we auto-indented all our C code so it looked consistent. I would try and clean out a lot of cruft that was there. And fortunately, for our project, we've been good at really eliminating that technical debt and coming in. The idea of coming in and I have to clean up this section. These function names don't make sense. We've got to split apart this big C file. Our build system needs to be overhauled. Are not really considered, do we have to do that? Everyone's like, oh, good, let's do that. That's hard to do, I think, in a commercial setting where maybe you have more immediate deadlines, where you're looking 3 months out, 6 months out. I think one of the real benefits that we had in hindsight, again, we look like genius, but we inherited the code was already 10 years old in '96 from Berkeley. So it already was 10 years old. None of us had been original Berkeley people. So.
And you're also coding to get it right, not coding to get to a deadline.
Right. So we basically had this 10-year-old code, and you're looking at it, and you recognize some of the names, from even guys I meet at conferences and stuff. And you're like, okay, so now we're kind of stewards of this 10-year-old code, right? So you're not basically starting with a blank slate and saying, let's get to something production in 3 months or 6 months. You've already got a 10-year-old code. So you're thinking, okay, if it's been around 10 years, I got to get it up to standard. So new people, it doesn't look like 10-year-old code, right? But then second, well, if it's 10 years old now, then I got to think 10 years in the future, 20 years in the future. And that's one of the, I think, key things that has given us that longevity. There's a lot of expedient things we could have done years ago to accelerate where we were. But I often feel that expediency over time really corrodes the development team and how they view the code, and it erodes how people see your code and how the reputation of the project. So we've never had that kind of deadline. I'm proud, as I said this morning, that we continue to crank out a yearly release that has 170 to 190 features roughly. But it's not done in a way that's rushed. It's not done in a way that really feels like, oh, we got to do something. If we see something that's got a delay, then we do it. I spoke yesterday about we had a 4 or 5 month delay when we did JSON-B because the compression wasn't acceptable. One person reported it, and we looked at it and we're like, wow, that's, and yeah, we delayed, we restructured that because we knew once we shipped it, because of the way we don't change the data format, that would be over. So a lot of it is thinking of yourself not as producing a result, but as a steward of work that has been done in the past, and as a steward of those who will come in the future who are going to continue working on that code. So I don't know a lot of projects who maybe have that outlook. I'm sure some do. But I think that is a key aspect of how we've stayed so long. And also, I think a testament to why there's so many projects that use the Postgres source code for new databases, because it is very well structured and very easy to work with. We don't pay our developers, obviously, so we've got to make it as easy as possible. And those simple things, I think, pay great dividends.
Well, one of the things I want to tell the audience listening, I'm sure all three people who eventually hear this will want to know this. Years ago at the Southern California Linux Expo, I went to one of your talks, and people were saying, why is the MySQL guy here? Well, you are a brilliant lecturer. Your slide decks are brilliant and concise, and I always learn something. And now that I'm in an arena where I get to play and relearn Postgres, I am more impressed than ever. I am a fanboy. And congratulations on getting the help. Is there anything else you'd like to expound on, rant, rave, go off on a tangent?
Yeah, it's just wonderful to be back with everybody. I'll tell you, Austin, this is a wonderful venue, wonderful conference. My first time at the U.S. Percona. I've only done the European one once, so I'm hopeful to be able to come back again.
We're going to have two next year.
Oh, two next year.
Yeah.
Okay.
One here.
All right. Good. So yeah, I'm really enjoying. I'm hoping we continue to grow the event and people see the value of coming to conferences, really sort of spending time together. You and I spent time together in the past, and virtual is kind of over. People were really ready to get back together.
The hallway track is back.
Yeah. So I'm really basking in that as an enjoyment.
Well, thank you, Bruce, for taking the time to talk.
My pleasure.
Congratulations again.
Thank you.
Folks, we are at Percona Live 2022, and traditionally Matt Yankovic would be doing interviews with the folks who are attending. And one of his favorite podcast subjects is Charly Batista. And since Matt's not here, we're going to make a talk dedicated to him. Matt is recovering from an illness, and he's doing fine. But he will want me to say, Charly, what is up with Postgres backups?
Well. So today you're gonna do a podcast that really works, right? So I think we should start. Well, I haven't talked about backups, but you know that you started talking about that. I told him that I bring him some coffee, and I have some coffee, right? And because he said he kind of like coffee, but I said, no, you've never tried a really, really good coffee. But have a good coffee.
Well, I'll be shipping a bunch of stuff back to him, like a Yawn box and some other stuff, so I can throw that into it.
Oh, yeah, that would be pretty cool. But back to the backups. What was the question? I lost myself.
Well, I remember of talks with Matt about backups, and he could never quite get you to get to the point of how to do the backups themselves.
He messed up the server. That was a problem, you know. The last session that we did, I needed to back up the database server, but there was not database server. The database was not there, and I asked him to create a new driver from AWS, and the driver was not there either. So, and then like, how can I do a backup from a database if you have no databases, right? Wow. And then he was blaming me, because you cannot do the backup, but no, you don't give me a database. And he said, no, it's your database. How is it my database with your machine, right? So yeah, it never worked, right? But then I spin up a new machine. Now that machine that works, because I did that one, so that works, and we can finish the stuff. Okay.
Great. Now, you're one of our resident Percona's Postgres experts. How did you stumble upon Postgres? I mean, Microsoft Access does everything we need, right?
Yeah. Yeah. Oh, that's wild. No, that's wild. Yeah. About the Postgres, we've been doing a lot of nice stuff. Well, like at Percona, we've been doing a lot of nice stuff.
I mean, the PG stat monitor.
The PG stat, exactly. Yeah.
How do you get that level of granularity on a running query to be able to tell you what it's exactly doing?
No, that's highly complicated. One, we usually compare with what we have in the market, right? So, for example, it would be a fair comparison to compare with PG-stat statements. That's a tool that we have in the market. So they do similar job at some extent, at some point, and then PG-stat monitor start diverging a lot when we start getting flame graphs and those informations. A lot more granularity on the statistics, and altogether when it goes to the PMM, so that you have the query analytics, that's a very powerful tool, really powerful tool. So it's quite a lot easier to see what's going on your database, what the queries that are shooting on the foot, right? Sometimes you have a couple of queries that they're really messing up with the database, taking the performance really down. And the combination of the PG-stat monitor and the PMM, you can see graphically. And even if you do not use the PMM, you can get a lot of that information from Postgres as well, right? Because it's an extension of them. So if you don't have the bandwidth or don't want to use a graphical tool, if you like, a lot of people, they don't like graphical tools, I don't blame them. And you can go for the database, right? You can collect that information. So most of them are exposed from the database as well. So it's very powerful. It's really powerful.
PMM, if you don't know, is Percona
Monitoring, yeah.
And measuring. And it is a free open source tool. It works with MySQL, MongoDB,
And
Postgres, and ProxySQL. Also tells you the underlying health of the server. The last time I was really running Postgres in production was many jobs ago. And the first word of advice I got was make sure you are running vacuum. Has vacuum changed a lot in the last 10 years?
Not much. The idea is the same. Actually, the thing is how the Postgres is designed, how it works with the files, right? We're gonna have a talk here. I'm gonna have a talk here about vacuum, and we're gonna go into the internals, because really to fully understand why we need vacuum, we need to understand how Postgres stores the data, right? For example, if you delete a row, as it uses MVCC, you do a logical deletion on the database on Postgres, just like most of other databases, right? You do a logical deletion, but that row is not available for Postgres to reuse. So if you want to tell the Postgres to reuse that row, you need to go there, run a vacuum process, and you then mark that row to be reused again. Another thing that sometimes people do not understand or do not know is Postgres doesn't have undo logs. The undo logs on Postgres are on the data tables. For example, you start a transaction, right? I start a transaction to insert to the table user. And before you do any commit or any rollback, your database crashes. So when the database comes back, we expect the database will check the undo logs, right? And roll back that transaction because it's not committed. That it's now on the data tables, it's on the files. So if you do not run a vacuum, you to occupy space on that files, right? And understanding those things, when we start understanding those things, we start understanding why we need vacuum and like what does it do by. And another really big problem that I've seen people talking here, I've heard people saying that they're running on those problems, are the infamous ID wraparound. XID wraparound is a problem that's been on Postgres since ever, especially because it's for every transaction, It has one identifier, right? A transaction identifier, and it's 32 bits. So when it was designed like 20 years ago, 30 years ago, it was not a problem. Like we used it to have 32 bits CPU architecture. We didn't have that many transactions. But now companies, they have millions of transactions per second, right? So to exhaust the 32 bits integer, it's sometimes it's a matter of days or weeks, right? And people, they do not understand the criticality of those things. The thing is, if you let it to wrap around, it's just gonna stop your database. There's nothing else to do. You're gonna stop your database. And then you need to start your database on single user mode, no transactions allowed, anything, and then you go there and run a run. Right? So it's very critical. And it's been since ever. Like since Postgres is Postgres, we still have those problems. So answer your question, nah, it didn't change much from the last 10, 15 years.
And you have, what, 6 sessions here this week?
No. I had one tutorial yesterday. It was really great tutorial. We're talking about high availability and how to scale Postgres. It was quite cool. Today, I have one that I'm going to share with Agustin, that we're going to talk about Postgres and PMM, how to use PMM for monitoring and to get cost improvement, right? And another one that I'm gonna talk about internals. It's a previous one from Vacuum, is how Postgres stores data, how it stores internally, and how we can use this knowledge to reduce costs. For example, I did some tests and a very simple table that I had like a million rows, and I just changed the order of the columns, and I saved 20% disk space. And sometimes this disk is cheap, right? So we buy for cheap, like on the cloud. But the problem is everything that goes to the disk, when you're reading, it goes to memory, right? And well, memory is more expensive. I also remember that when you have a replication, everything that you save to the disk needs to be replicated, goes to network and all the complication and everything. So if you can save like 15% disk space, it's 15% less thing that needs to be replicated, right?
Very cool. As someone who grew up, my first professional job was on a machine with 384K words of memory, and we supported 36 interactive people on there. And I remember adding my first disk drive to it, and I had to use a crescent wrench because the thing was the size of a dishwasher. So,
yeah.
Well, folks, this is why you want to come to Percona Live in 2023, because we're going to be in the US and EMEA. Hopefully Charly will be back. Also, Charly is one of our Postgres experts, so if you need help under Percona, we will do what we can to get you learning. And thank you, sir.
Thanks, Dave. That's really great. Talk to you.